Welcome to our video on section 3.7 of the Red Book, Cost, Income, and Value Problems. To begin, we want to recall some formulas. The first three are very similar in nature. For cost, we want to think about the number of items times the price per item. For example, if you buy 3 t-shirts at $5 each, that's $15. Income is going to be the number of hours worked times the wage per hour. So in a similar way, if you get $10 an hour babysitting and you work for 3 hours, 10 times 3 is $30. That's your income. Total value is going to be, again, a number of items times the value per item. So let's say that you have something like a cup collection and you have 10 cups and they are each worth $10. You would have $100 in total value in your cup collection. The one that is slightly different is our profit model. Now think about profit in terms of you are going to sell something, so we're going to take our sold amount and subtract out what we bought it for. We can also think of that as sales, just another way to say sold minus cost. So for example, let's say that you bought 10 t-shirts for $5 each. Your cost is $50, but you turned around and sold them for $8. So then you would make a profit based on your sales minus your cost. And we'll look at that when we get to our last example today. All right, so in all of these, we're going to use a chart method. And across in the, again, we've already covered charts. So this is just to reiterate, the rows will be our differentiating items. And then across the top, we're going to put some form of number times value equals total value. So here we have ticket to a concert, and we have adult tickets and student tickets. And so we want to think in terms of the number of tickets times the value for each ticket, and that's going to give us our total value. So in this case, I have the value is given to me, $8 for adults and $4 for students, and we have a total number of $9.20. So I'm going to put that at the bottom here, and then I'm going to think in terms of, since we want to know how many adult tickets, I'm going to make that my X. Well, if there were a total of 920 tickets sold and X were adults, then the remaining student tickets must be 920, our total, minus the adult tickets, or minus X. The third column is always an algebraic expression, number times value. And we don't want to forget to put our parentheses when we have a binomial expression. Now again, here it said that the tickets were worth $5,760. So that's going to be our total value of adult and student tickets. So what we're going to do is we're going to say our value of adult tickets plus our value of student tickets is equal to our total value. And our equation will look like this: 8x plus 4 times the quantity of 920 minus x is equal to $5,760. So if we were to solve that, which I'm actually not going to do here in this video, we would end up getting that x is equal to 520. So our answer here, because I assigned the value of the variable to be what we were looking for, it's a simple answer of there were 520 adult tickets. Always remember to answer the question that was asked. So in this question, I made my life a little bit easier by making my X what we were looking for. All right, so let's go ahead and look at number 2. And again, on most of these, I'm not going to do the solving, but rather just the setup. All right, so here we have plain caps that cost $4 each, and deluxe ones cost $6 each. the total bill was $236, and we want to know how many deluxe caps were sold. So this is fairly similar to our last problem in that we have two categories, plain and deluxe. And across the top, I'm going to think in terms of number. I'm going to do price because these are priced at a certain amount, and that's going to equal our total cost. So again, you could write total value. I'm not so concerned about how you label those as much as that you understand how they're getting the third column. So here the plain caps cost $4 each and the deluxe ones are $6 each. So I fill that in first because that's my easiest piece. There were 40 students, and we know that they bought, again, everybody bought one. So I'm going to put the 40 at the bottom of the number here. So it's asking us how many deluxe caps were sold. So just like I did in the last problem, I'm going to make that my x so it's easier for me to answer the question at the end. If 40 is my total and x is my deluxe, then plain must be 40 minus the deluxe. And so very similar, we're just going to multiply. Always remember this third column is an algebraic expression. And because the total bill was $236, I can put that under here, and we're going to say the cost of the plain caps plus the cost of the deluxe caps equals the total cost. And our equation would look like this. 4 times the quantity of 40 minus x plus 6x is equal to 236. My hope is that you see how closely that resembles the last question. All right, so again, I'm going to leave the solving to you, and just know that when we solve, we're going to get x is equal to 38. Because we made our variable what they were asking for, we can go ahead and just say there were 38 deluxe caps sold. Now, would it be wrong to put the x as the plain caps? No, then you would have gotten a different number. You would have gotten 2 for your x, and then you would have to go back and plug that in to get the 38. All right, so let's move ahead to number 3. And the difference with this question is that we've got a coin problem. Very similar, but what I want to show you is how we can, instead of using decimals, we can think in terms of cents to set up our chart. And when I say cents, I mean like there's 100 cents in a dollar. So I've got a collection of 60 dimes and nickels, and it's worth $4.80. We want to know how many dimes are there. So I'm going to start with my chart, and I'm going to make my dimes row and my nickels row. Now, of course, if we had more than just 2 types of coins, we could make a third row. We have the number of coins times the value, and that's going to give us our total value. Again, it tells you nothing about how much money I have if I say that I have 10 coins. It's only once we know the value of those coins that we know how much money I actually have. So because we want to know how many dimes there are, I'm going to put that for my x. And we have a collection of 60 dimes and nickels. So if I have 60 coins altogether, if x of them are dimes, then the remaining would be 60 minus x. So for example, if I have 10 dimes, then 50 would have to be nickels. Now, here's where it's going to be a little bit different. We know that the collection is worth $4.80, but rather than using decimals, which most of us don't like, what I'm going to do is I'm going to think in terms of a dime is 10 cents, a nickel is 5 cents, and so $4.80 is 480 cents. So in other words, if I don't use decimals in my charts, I wouldn't want to use decimals for my total value. This just prevents me from having to clear the decimals in my equation. So again, similar to the last two, I'm going to multiply number times value, being careful to put those parentheses in when we need it, and we're going to see that the value of the dimes plus the value of the nickels is equal to the total value. So our equation would look like this. 10x plus 5 times the quantity of 60 minus x is equal to 480 cents. And when we solve for this one, we're going to get x is equal to 36. There are 36 dimes. Now, these can get trickier. We're showing the basic type of chart problems. And so as we do the homework, you'll see some that are just a little bit different, maybe with 3 coins or some variation there. All right, so let's go ahead and do our last problem. As promised, that one is going to be our profit question. And these can be just a little bit harder. So here we have Henry paid 80 cents for each bag of peanuts. He sold all but 20 of them for $1.50 and made a profit of $54. How many bags did he buy? So now instead of thinking in terms of, right, we've got peanuts, so we can't differentiate 2 items. So what we want to think about is what he bought them for, or again, depending on how you see it, you can think of that as his cost. And then the other row is going to be what he sold them at, or his sales, the money he brought in from them. All right, so across the top, though, we're still going to have number. So he's sold, again, so many bags. And we're still going to have the price. So he had a price when he bought them, and he had a price when he sold them. And then when we multiply number times price, we get the total value associated with that. All right, so let's go ahead and highlight a few things. He sold all but 20 of them for $1.50 and made a profit of $54. So let's go ahead and put in the, he paid 80 cents for each. Now here I am going to keep the decimals because I've got $1.50 and then the 54 would be a little bit big, and plus it will show you both ways to do the problem. So I'm going to put $1.50 there, and we know that he sold all but 20 of them, and we want to know how many bags did he buy. So in keeping with what I've mentioned, it's easier if we make our X what we're looking for. So we're looking for how many bags he bought. So I'm going to use the X there, and he sold all but 20 of them. In other words, he didn't sell as many as he bought. He sold 20 less than he bought. He couldn't possibly sell 20 more than he bought, so that's going to be X minus 20. This column, just like it has in the other questions, is going to be number times price. And here I'm just going to leave off that 0. And again, we know that he made a profit of $54, so I'm going to put that here, but don't forget, going back to your original notes, what we're going to do is our sales minus cost is equal to profit. So what this is going to look like, I'm just going to do this in a different color, is going to be the sales, again, that should be more if we're making a profit, and then we're going to subtract the cost, and that's going to be equal to our $54. So rather than adding the two, we're subtracting the smaller one from the bigger one. All right, so again, I'm going to go ahead and solve this one just because I haven't solved any of the others. So when I distribute the 1.5, I'm going to get 1.5x, and that's going to be 30 minus 0.8x. I'm going to collect my like terms, so we're going to collect the 1.5 minus the 0.8, and that's going to give us the 0.7, 0.7x. Minus 30 equals 54, and I'm going to add the 54 to the other side, and that gives us 0.7x is equal to 84, and when I divide both sides by 0.7, I'm going to get that x is equal to 120. So my answer here, because they were asking how many he bought, is that Henry bought 120 bags. Now, it should make sense, right, that he would have to buy more than he sold. And it would also hopefully make sense that his cost should be less than his sales in order to make a profit. So this concludes our examples from this video. So bring your questions to class and we'll be working on the homework.